today we're going to be looking at probability tree diagrams and how you draw them. Tree diagrams are a great way of representing your probability problems, giving you a visual representation of the problem that you're going to be tackling, so they can be useful in a whole range of situations when solving probability problems. So the first example that we're going to be looking at today is when the two events are independent, which means that both events can both happen at the same time and they're not dependent on each other, or which we'll be coming on to in further videos. So the first example we're going to be looking at is the probability John has beans for dinner is 0.3. As well, the probability John takes his dog for a walk is 0.8. So, using our tree diagram, we want to find out the possible outcomes of all these scenarios. So whether that's John has beans for dinner and he takes his dog for a walk, or he doesn't have beans and he takes his dog for a walk. And this is what we're going to be working out on our probability tree diagram. Okay, so each of the branches represent a possible outcome. Okay, so on the first branch of our tree diagram, the two outcomes show us that John can either have beans for dinner or he can not have beans for dinner. From the question, we know that the probability that he has beans for dinner is 0.3. So we're going to assign this value to this branch, 0.3. As we know that all probabilities have to equal 1 when they're added together, as this is a certain outcome, we can do 1 minus 0.3, which equals 0.7. So now we know that the probability of John not having beans is 0.7. We then move on to our second stage of the tree diagram, and as you can see, each branch has two more branches sprouting off it. This is because if John either has beans or no beans, we then have to decide the probability of whether he's also going to take his dog for a walk or not going to take his dog for a walk. We know from the question that the probability that John takes his dog for a walk is 0.8. So applying the same logic as we did last time, we can assign these values to these branches. Okay, so the probability that he takes his dog for a walk is, as we know, 0.8. When we do 1 minus 0.8, we get 0.2, as we did before. 0.2. We can then literally copy this straight down to here. So we've got again 0.8, the probability that he takes his dog for a walk, and 0.2 that he doesn't take his dog for a walk. Okay, so now we've put all our values onto our tree diagram, we can then start to work out the possible probabilities of these outcomes occurring. Okay, so to work out the probability of John having beans for dinner and taking his dog for a walk, because the two events are independent, we can use the multiplication rule, which essentially means we can multiply these two values together. So when we multiply together 0.3 and 0.8, we know that the answer is 0.24. Okay? We can apply the same thing to beans and no dog walk. We do 0.3 times 0.2. When we multiply these together, we get 0.06. Okay, moving down to if John does not have beans for dinner, we have got 0.7 and 0.8. Times them two together, we get 0.56. And again, for the last outcome, we've got John does not have beans and he doesn't take his dog for a walk. So that's 0.7 times 0.2, and we get 0.1. Okay, to check you've got the right answers for when you've used your multiplication rule, the best way to do it is you add all of these values up and the answer should be 1, as that is a certain outcome and we know that all of these are possible outcomes. So, yep, so when we add all these together, we know we get 1, so we know that we have the correct answer.